We are now moving on from simple interest to compound interest. So before we begin doing that, let's just get some practice with using exponents in our calculator. So make sure you have the button on your calculator. It'll either look like x to the power of y or x to the power of 2, something of the sort. It might even have like a little box up there like that. So you're going to have to know how to use that button because we're going to have to be using powers with this formula. So let's try these examples at the top. So 3 to the power of 3, if we plug that in our calculator, you should be able to get 27. 2.5 to the power of 2. And I should just reiterate here that when we're doing 3 to the power of 3, that's the same thing as doing 3 times 3 times 3. So you're multiplying 3 times. When we do 2.5 to the power of 2, we're going to be doing 2.5 times 2.5. So we're timesing 2.5 twice. So if we plug that in our calculator, you should get 6.25. For number 3 here, if we're following BEDMAS with these, we would do everything in the brackets first. So we would begin by doing 2 plus 3, which is 5. And then we would do 5 to the power of 4. So if we plug that in our calculator, you will get 625. And then we're going to do the exact same thing for this one. So we'll do everything in the brackets first. So 1 plus 2.1, which is 3.1. And then that'll all be to the power of 3 still. So 3.1 to the power of 3 would be 29.79. So now let's actually look at the compound interest. So Madeline invested $10,000 4 years ago. The investment earned compound interest at 2.1% per year, compounded annually. She will use the interest to buy equipment for her cupcake business. How much interest does Madeline have for the equipment? So the difference between compound interest and simple interest is that with simple interest, we only applied the interest to that initial amount. However, with compound interest, we're going to be finding the interest multiple times. So this word compound, I like to think of it like collected. So if they're collecting this interest annually, as it says up here, that means they're going to collect interest once a year. So annually, that means once a year, kind of like an anniversary. Annually, it's once a year. So once a year, they're going to calculate this interest. And when they calculate the interest, they're going to add it to your initial amount, your principal amount. Then the next year, when they calculate the interest again, the interest is also going to be affecting the interest that you added on the first year. So let's look at this chart and see what this all means. So year 1. The principal or the starting amount at the beginning of the year is $10,000 because it says she invested $10,000. So if we use the simple interest formula, we would do I equals PRT. So we have the principal amount, the rate, and the time. So the time this time is 1 year. And the rate, it says 2.1%. So then they switch that to a decimal. So if we multiply that all together, we get $210 as the interest. So then we can find the amount of money that she has by taking the initial amount, $10,000, and adding that interest on, that $210. So at the end of the first year, she's going to have $10,210. So then now that she's doing this for 4 years, as it says up here, let's move on to the second year. So the second year, we're now going to take this amount she had at the end of the first year, and that is going to become our new starting amount. And we're going to have to calculate the interest on this new amount. So we're going to have a new principal, which is 10,210. The rate is going to stay the same, 0.021, or that's 2.1%. And we're only adding on another year here. So the year is going to stay as 1, as we're going from year 1 to year 2. So that's 1 more year. So if we multiply all these things together, you should get $214.41. So you'll notice that the interest this time is a little more money than it was last year. And that's because we're calculating the interest with the interest of the last year added onto it, onto the initial amount, I mean. So now let's add this interest onto the initial amount from this year. So we're going to do 10,210 plus $214.41. So if we add those two together, the amount she will have at the end of the second year is $10,424.41. So we're going to continue doing this to fill out the chart. So now I'm going to take this amount at the end of the second year, and that's going to become the initial amount we have at the start of the third year. So we're going to have $10,424.41. So we're going to do all these calculations again. $10,424.41. The rate is staying the same, 0.021. And then the year again is 1. So we're going to multiply all of these together. And the interest you would have is $218.91 this year. So again, it went up from the previous year because now our initial amount has a little more on it because we had to add that interest from the last year. So finally, the amount would be $10,424.41 plus that interest we just calculated, $218.91. So in total, at the end of the third year, she would have $10,643.32. I'm going to fill out the last row of this chart and then we will cut back. So I finished filling out this chart and our final amount after the 4 years that we have is $10,866.83. So using the simple interest calculations with this chart, we determined that after 4 years, Madeline's investment is worth $10,866.83. So to calculate how much interest we actually added on here, we could take the last amount we got, so with the interest combined, so that's at $10,866, and we would subtract the initial amount from it, that principal amount, which was $10,000. So that's what she originally started with at the beginning of all of this. So if we subtracted those two numbers, we would get $866.83. So Madeline has $866.83 in interest for the equipment. So that's how much interest she earned there. Now, the method we use to calculate this compound interest is more complicated than it really is. This was just showing you what it really means, but we actually have a formula to make our lives a lot easier. So this here is the formula that they give us for compound interest. So make sure you have this one written down. We have the amount is equal to P, which is the principal, times 1 plus I, and I in this case is the interest per compounding period, and then to the power of n, and n is the number of compounding periods. Now note that with this compound interest formula, we're not just solving for the interest this time. We're not solving for I, we're solving for A, which is the amount. And if we look at the previous formula for simple interest, we were solving for capital I here. We were solving for the interest with the simple interest. And then in order to find that final amount, we had to use this other formula where we took the initial amount and added the interest on. So with the compound interest formula, we actually could skip that step, that second step of finding that final amount, because this entire formula solves that for us. So let's look at example 1. We're going to use the same example we did up here, except we're going to use the compound interest formula. So we're going to use the compound interest formula to calculate how much interest Madison earned, and we should get the exact same answer as the first one for this. So solution, what information do you know? The amount. Well, we don't know the amount yet. That's unknown, so that's why they put a little question mark there. But we do know the initial amount, or the principal, is $10,000. Now, the interest rate per compounding period, which is lowercase I, is 2.1%, but we never use the percent number. We actually have to change that to a decimal, so it would be 0.021. And the number of compounding periods, that's going to be the N. So if we look at the top, how many times are they going to collect this interest? Well, they collect the interest annually, meaning we said once a year. So we have to look and see how many years is she doing this for? Well, she's doing it for 4 years. So if they compound it once a year for 4 years, that means they're going to compound it 4 times. they're going to collect that interest 4 times. So the number of compounding periods would be 4. They collect the interest 4 times. So for B, what is the total amount that Madeline had after 4 years? So now we're going to plug everything into this formula. So P, we have $10,000. Lowercase I is that rate, so we have 0.021. And I don't know why they use an I for this. I would prefer for them to use an R, because in the previous formula we used, it was an R. So I don't know, you could kind of consider that to be an R, where that lowercase I is. And then N is the amount of compounding periods. So we said that's 4. So they actually plug this in for us here for the N. So that's to the power of 4. Now, if your calculator is a scientific calculator, you can actually plug all of this in straight away. If you write it down exactly as I have it here with the brackets and everything, you would be able to get the final answer. However, if you don't have a scientific calculator, you will have to follow BEDMAS. So in order to do BEDMAS, we would start with everything in the brackets first. So that $10,000 on the outside will stay the same. But then in the bracket, we're going to do 1 plus 0.021. So that would be 1.021. And that's all still to the power of 4. So then if we're following BEDMAS, we would continue with the exponent next. But keep in mind that this exponent is only attached to this in the brackets. So we're going to do in our calculator 1.021 to the power of 4. So that $10,000 is going to stay the same. And then 1.021 to the power of 4 is equal to 1.08668. And now our final step is to multiply 10,000 times 1.08668. So if we do that, we will get the final answer of $10,866.83. And if you notice, this answer is the exact same thing that we got in the first question, or in the first example we did, where we used the simple interest formula to calculate this. So both methods will work. So now, how much interest did she earn? So remember, this formula gives us a final amount. So what we want to do is to just calculate the interest is we take that final amount and we subtract the initial amount from it, which was $10,000, that principal amount. So then we get $866.83 for the interest. Let's try one more example. So Owen sold his auto body shop in Regina. He invested $80,000 in a savings account that earned 2.75% a year, compounded annually. How much will Owen's savings be worth after 3 years? So determine the value of Owen's savings. So we need to determine all of these letters first, all these variables. So P, his initial amount, well, he invested $80,000. So that would be the initial amount. Then if we're looking at I, or I like to think of I as the rate, so the lowercase r, that would be 2.5%, or if we switch that to a decimal, it would be 0.0275. And then for N, that's how many times they are compounding that interest. So if you see here, it's compounded annually, so once a year. And we are calculating how much it'll be worth after 3 years. So if they're doing it annually, which is once a year for 3 years, that'll mean our N is 3, because they're going to compound that interest 3 times once a year. So now let's plug everything into this formula. So we have $80,000 for the P. Then in the brackets, it's 1 plus the rate, or the I, which is 0.0275. And then the N is 3, which they gave us there. So then if we multiply all this like we did in the previous question, we should get $86,783.16. So Owen's savings will be worth $86,783.16 after 3 years.